Good day, grade 12s. In the next series of videos, we're going to look at the concept momentum as it is required by the CAPS document for grade 12. Now, what exactly is momentum? Momentum of an object mostly depends on the amount of matter that it consists of, as well as the velocity it travels with. So let's formally look at the definition of momentum, which you should be able to give in the exam as well. Momentum is the product, so you times the mass and the velocity. Momentum is the product of the mass and the velocity of an object. We can represent this with a formula. Momentum is represented by P, mass by M, and V gives me the velocity. I made this or came across this visual which I thought might give you a nice memory hook for the concept of momentum. There you have a relative big mass running at a relative great speed. So this guy has a relatively large momentum. The unit for momentum is kilogram meters per second. That's not too difficult to deduct because we know momentum is the product of the mass, which is measured in kilograms, and velocity, which is measured in meters per second. So the unit for momentum will be a combination of these two. But do pay careful attention. The mass in momentum is measured in kilograms. So if sometimes in problems they give you a mass in grams, it is very important that you convert that mass. Another problem which you'll also find is that they sometimes give you the velocity in kilometers per hour. In order to do momentum calculations, it is important that when they give you a velocity, you convert that to meters per second as well. Momentum is a vector. That means it's got magnitude and direction. So now let's look at this example. A bird on a tennis ball has a joint mass of 750 grams. So there already you can watch out that 750 gram, I know I must convert to kilograms as 0.75 if I want to calculate the momentum. He moves at 0.2 meters per second to the right and then at 0.2 meters per second to the left. So there is my image of my bird as he moves around. And I'm going to show you how we represent the momentum of this bird. Well, this bird is first moving in one direction to the right and then moving in a different direction to the left. Since momentum is a vector, it is very important that we choose a direction as positive and another direction as negative. So for this example, I'm going to choose to the right as positive. So now if I want to calculate this bird's momentum to the right, we first write down the symbols. P equals mv, the formula for this calculation. And then because it's moving to the right and I chose right as positive, I'm going to use a plus sign and say my momentum is going to be equal to plus 0.75, that's converting the grams into kilograms, times the velocity, which is 0.2, which will give me an answer of positive 0.15. When you, however, solve momentum problems, do not leave your final answer with a sign, a plus or minus sign in front. Usually, learners do not leave it with a plus sign in front, but often with a minus. So make sure that you do not include any final sign in your final answer, but interpret that sign as a direction. We chose positive to the right, so we know if we end up with a positive number, it means that our direction is to the right. Now let's look at the same bird, but now we want to write down his momentum to the left. I chose to the right as positive, so to the left will be negative. And if I write this down, I'll first write down the formula, P equals mv, and then I'll substitute the values that they give me in the problem. In this case, I'm looking at the velocity to the left, so I know it's going to be a negative number, and that's why my momentum is negative, and I end up with negative 0.15 kilogram meters per second. I cannot leave the answer like that as a final answer. I have to interpret this answer I have to interpret this minus sign as a direction and write my final answer as 0.15 kilograms meters per second to the left. Do not have any signs to indicate your final answer as positive and negative. Remember, the positive and negative is only there to indicate to you in which direction this vector is working. So that direction you have to indicate in your final answer. Be very careful to do that consistently. Often in the exam, we find that learners omit the unit as well as the direction, and that will cause them most surely to lose marks. Okay, let's look at another example. A 5,000 kilogram bus travels to the west at 10 meters per second. Calculate its momentum. First thing that you always do in momentum calculations is decide on a direction that you choose as positive. There's no real reason why I chose west as positive, except that this vehicle is only moving to the left. You can choose any direction, but you have to stick with that direction throughout your sum. So if I choose west as positive, then I know my velocity is going to be a positive 10. So the first thing that I do, I write down the appropriate equation, and then I substitute the values that I have from the problem that I'm presented with. I know my mass is 5,000 and my velocity is 10 meters per second. I know that they are the correct unit, so I don't need to convert. And my final answer will be 50,000 kilograms meters per second west. Okay. Just to consolidate this whole concept of momentum, why don't you go to worksheet and do the first sum? After you've done that, this sum will be marked in the second video. Please do the sum first and carefully mark it to make sure that you understand this concept well.